The next section is about the exact values of trig ratios. Now I know you can work these out on your calculator, but it's useful to know, like off the top of your head, things like cos 60 is a half, or tan 30 is 1 over root 3. Those types of things are useful to know. It's a very short section, but it's worth just going through how we can find the exact values. So if we start off with a isosceles triangle where both of these sides are 1, that means that these angles here are 45 degrees. And using Pythagoras, this side is going to be the square root of 1 squared plus 1 squared, which is the square root of 2. Okay. We can do the same thing with an equilateral triangle. Let's say all three of these sides are 1. That means that all of the angles are 60, like this. But what we're going to do, we're going to chop this in half. We only want half of it. So I'm going to take this bit away here. So what happens now is this angle at the top is now 30, and this side is a half. And then if I use trigonometry, then if I use Pythagoras, this side is going to be the square root of 1 squared minus a half squared, okay, which is basically 1 minus, now a half squared is going to be a quarter, so 1 minus a quarter is 3/4, so we've got the square root of 3/4, which is basically root 3 over 2. So this side here is root 3 over 2, and we can just use Pythagoras to sort of help us work out that. Okay, so what we've got here are two triangles where we know the exact length of each side, and we've got 30 degrees, 45 degrees and 60 degrees. So what I'm going to do is I can work out the sine, cos or tan of either 30, 45 or 60 degrees. So let's start with sine 30. Okay, so sine 30, so if I go to this triangle here, sine is the opposite over the hypotenuse, so it's half divided by 1, so it's a half. Cos 30, well, if I look at this triangle, it's going to be the adjacent over hypotenuse, so root 3 over 2 divided by 1, which is going to be root 3 over 2. And then tan 30, well, tan 30 is going to be the opposite over the adjacent, so it's going to be half divided by root 3 over 2, and if you do that you get 1 over root 3, which is the same if you rationalise the denominator as root 3 over 3. It's the same thing. Okay, so here we've got the exact values of sine, cos and tan for 30. So let's go now to 45, since that's the next size angle. So sine 45, cos 45, tan 45, and we're going to use the triangles again, but this triangle over here. So sine 45, again doing the opposite over the hypotenuse, will give you 1 over root 2. If you rationalise the denominator, that's root 2 over 2. Cos 45 actually gives you exactly the same value, so I'll just put that out as the same thing. And tan 45 is going to be 1. And then lastly, if we look at sine 60, cos 60, tan 60, and we'll do the same thing with this triangle over here. And the values we're going to get are root 3 over 2 for sine 60, a half for cos 60, and root 3 for tan 60. Now we can use these exact values along with the cast diagram to extend like the different angles that we can find. So for example, let's say if I wanted to find sine 150, okay, so draw my cast diagram, put on 150 degrees, which is there, that's a gap of 30 degrees, make it into a cross so I can find all the symmetry. That means all these little things here are 30 degrees. Okay, put on CAST, I'm on the part of the cast diagram where 150 is over here, where sine is positive. Where else is sine positive? It's only positive over here. It would be negative below the axis over here. So if I know that I want to find the exact value of sine 150, well, it's the same, according to my diagram, sine 150 is the same as sine 30. Right, okay, so sine 30 is a half, so that means that sine 150 is a half. Now remember before we looked at the angles which were like in the right symmetry but in the wrong place. So for example down here, this angle down here, that would be sine, either sine 330, or I could write that as sine minus 30. Now remember, it's the right size, isn't it, but it's the wrong sign. So this would equal minus a half. Yeah. And the same with this angle over here. That angle there, that's sine, you could call it 180 plus 30, so sine 210, which is the same as sine, if you go backwards, negative 150. And again, it's like the right symmetry, but it's the wrong sign. It's negative down here, so it's equal to negative a half. And you can do all sorts of things with this, knowing these exact values and using this cast diagram. So the cast diagram is very, very powerful if you know how to use it correctly. Yeah, so just remember about drawing this cross here and looking for where the signs are the same. Yeah, this will tell you, these letters tell you whether cos is positive, tan is positive, sine is positive, or whether they're all positive. And if it's in the other part of the cross, the bit that you don't want, well, actually it's equal to the same value but the opposite sign. So negative a half, negative a half. So once you know how to use it properly, it's really powerful and makes questions really easy.